This video lesson is for Chapter 5, Part 3, Electrical Circuits. An electrical circuit is a network in which electrical charges can flow continuously in a loop. And the one on this diagram is the electrical circuit of a car. Now, the ones we're going to learn about are way simpler than that one. To be called an electrical circuit, there needs to be a minimum number of components. The first one is a power source, which is going to give energy to the circuit. The second one is a resistance, which is an object which is going to use energy from the power source, such as a light bulb. And to connect everything together, we need wires. Now I'm going to give you a bit more details about those three main components. The first one, the power supply, also called the power source. It's defined as the object that creates a potential difference that's in volts, so that's also called voltage. Or we can say that it's the one that transfers energy to the charges in the circuit, and it allows every other circuit component to work. Now, there are many different power sources or power supplies. You can use batteries, you can use the power outlet, you can use a photoelectric cell, which is basically a little solar panel. And these are the different symbols that we should know about power supplies, but the main symbol would usually be this one, where we have a small line and a longer one connected to wire. And the small line is the negative terminal, the long line is the positive terminal. The next component is the electrical resistant. This one uses electrical energy and transforms it into other kinds of energy. So it's going to go from electricity to radiant, thermal energy, or mechanical energy, for example. And electrical resistance is measured in ohms. And we're going to use an old letter that's a Greek letter called omega as the symbol for ohms. So we have light bulbs that can do that, and those are three different symbols that could be used in a circuit to represent a light bulb. A motor would be just a capital M in a circle. Heating element would be a series of bumps on the wire. But the main symbol for a resistance is wire, then zigzag, and wire again. And finally, now all of this has to be connected together to form a circuit. So we need wires for that. So they carry the charges from the power supply to the elements or electrical resistance, and then from the elements back to the power supply or the power source. They are the links between the circuit components. And the wire colors do not make a difference. They can be used anywhere you want. But by convention, the red one is often associated with the positive terminal and black wires with the negative terminals. But they could be any color, they all work the same way. And to represent a wire, we usually start the wire with a dot, draw the wire, and finish the wire with another dot. The dots show the connections between components. Now there are two main types of circuits. And here I have two sets of Christmas lights to represent those two kinds of circuits. In set A, if you follow the current, you see that there is only one path that can be followed to go back to the power source. So I can say set A can only form one path or one road. While set B, if I follow the current, here I can go into the first light bulb and come back right away, or charges could continue in the second one and then come back, and so on and so forth for all other light bulbs. So I can say that set B can form many paths. Okay, so we call set A series circuit, and set B is called a parallel circuit. I'm going to define each kind of circuit and give you an example. So a series circuit is a circuit in which components are connected end to end. There is only one possible path or road for the charges to travel through, and there are no intersections. So the charges never have a choice. There's only one road for them to follow. And the charges must flow into each component before returning to the power source. On the left, you have a drawing of a series circuit, but you need to be able to draw a circuit diagram of all kinds of circuits. So first we draw the power source, which is a battery. So small line, long line, small and long, because we have two batteries. We draw this twice. We do a circle to show the connection, and we draw only straight wires. Here we're going to draw the first light bulb and another loop for the second light bulb, and then we can come back and close the circuit on the negative terminal. To draw the light bulbs properly, we need to add a circle around them, and we can draw dots to connect the wires to the light bulbs. So if one component is defective in this circuit, nothing else will work in that circuit because the charges can no longer flow anywhere. There's a gap in your road. And at each resistor, that's each light bulb, energy is used. So that's going to decrease the amount of energy available for the other components in the circuit. The second type of circuit is called parallel, and that one branches out at least once. Or I can say that it has many roads to follow. It has intersections. That means that the charges have a choice. They can flow into different parts of the circuit, and the current doesn't have to flow through every component before returning to the power source. So let's draw a proper circuit diagram for a parallel circuit. So we start with the power source again, short, long, negative, and positive. Attach your wire to the positive terminal, and then we move up. We're going to create a first intersection that leads us to the first light bulb, and we can come back down, connect it to the power source. And that's going to be, oh, that dot's not okay, it needs to be on it, okay? And here there's an intersection as well. Now we draw the light bulb and its wires connected to the light bulb. Now that's the first road. There's a second part to the circuit. There's another light bulb. So we add another wire, a second light bulb, and connect it back to the second intersection. So add your circle, add the dots to show the connections, and that's the proper circuit for a parallel circuit. Now, if one component is defective here, the other circuit component will still work. So for example, if I cut off this wire, the current can continue and come back to the power source. So the second light bulb would still work while the first one does not work. And here energy from the power supply is shared equally among the circuit components. So in circuits, there are a lot of different things that can be connected to a circuit, but you need to know only the main symbols for the main parts. So a power source can have many symbols, but it's usually going to be represented like that. So negative terminal is a small line, positive terminal is a long line, and connected to wires like that. A switch is super useful. So we're going to draw a wire, a connection, the switch is open, another dot, and the wire. So the switch in that position shows that your circuit would be open. For a resistor, we would draw the zigzag. For a motor, it's a circle with a capital letter M with its wires. For a light bulb, here you have a couple of things. We can draw a little loop like that in a circle, or this way. This looks more like the ohm symbol for resistance, or it could be a different kind of loop, something like this. So you could see one of the three on any diagram. Now an ammeter, that's a super important instrument to measure your current intensity. We're going to do a circle with the capital letter A and its wires, and the voltmeter is an important instrument to measure the voltage in a circuit, also called potential difference. So that's a capital V in a circle. And just to become more familiar with the real instruments, that's what the power supply would look like. Ammeter, voltmeter. Resistors, they take different shapes and forms and colors, but they could look like those two examples. An electric motor. Our wires with crocodile clips, we use them because they're so easy to connect to other components. And the switches can take a bunch of different forms, but that's one kind that you might see in the lab.